Okay, here we go. Final lesson of this periodic table topic. Today we are looking at group 0, so the column on the end of the periodic table, and the transition metals, that big lump of them in the middle. Start a task relates to something that on the next slide, so I'm going to go through next. Halogens is what we looked at last time, and we've looked at group 1 as well, and metals and non-metals. They have reactivity. Group 0 is quite unlike those. If you have a look on the left-hand side, there's some real-world links, helium, neon, argon, krypton, and xenon. Keywords for this lesson are, so our purple words, noble gases, and then the transition elements or transition metals as well. So, questions on that I'm just about to click through. Try completing the questions. Answer any 2 questions from each row. Rows go across. The questions get harder though as you go down the table. So have a look, pause the video, pick any 2 from each row, complete them, and then work your way down. I would be thinking a good 5 to 10 minutes on this. So pause the video and have a go. The answers are about to come up. So there we go. There's the answers. So putting the 3 elements in order of reactivity. So if they're in group 1, reactivity would increase as we go down the group. So the most reactive would be further down the group. So in this instance, for this first one up here, potassium is more reactive than sodium, that's more reactive than lithium. If it's in group 7, remember that it's more reactive up the top, so that's why fluorine is more reactive than chlorine, which is more reactive than bromine, for example. Electron configurations, remember that's where the electrons are and how many electrons are in each shell. Hydrogen would just be 1, lithium 2 in the first shell, 1 in the second shell, aluminium 2 in the first, 8 in the next, 3 in the next because it's in group 3, calcium 2, 8, 8, 2, it's in group 2. Remember we can add all of the numbers up to find its proton number. 2 plus 8 plus 8 plus 2 is 20. You check calcium is element number 20. You'd find that to be correct on the periodic table. Can we name these things? So the metal always goes first. If there's just 2 elements in total, we would be an ide. If there are 3 elements in total, it would be an 8 if the third element is oxygen. So we have lithium bromide, sulfur dioxide. The di corresponds to the 2. Lithium nitrate, so lithium, nitrogen and oxygen, there's 3 elements, we call that an 8 if it's oxygen, so it is, so lithium nitrate. And the same situation here, we'd have copper, sulfur and oxygen, so that would be 3 elements, that would be an 8 because there's oxygen there, so it'd be copper, sulfate. Explain why one is more reactive than the other, so you can see that very tiny text and you can read through to check you've got the right answer for your questions. So, group 0. Remember, the group is the numbers across the top. So we've seen 1, 2, miss a few, 3, 4, 5, 6, 7, our halogens, and we would expect it to go to 8, but we don't, we say 0. The reason we say 0 is because, actually, if this was the top row and we went 1, 2, we can't call that group 2. We already have a group 2. And if we went 1, 2, 3, 4, 5, 6, 7, 8, and then the next one down, so that one, if we went to this one and we went across and we went 8, and then this fourth one down and we went 18, well, you can't call it group 2/8/18. So we just say, right, this outer shell of electrons is full. Well, let's represent full by calling it group 0. Okay, label that as the noble gases on your periodic table. Notice it's noble, not Nobel, like the Nobel Prize. Okay, what do we know? What do we know about the noble gases? What can you tell me about them based upon the periodic table, and how do they compare to other groups? Rack your brains, have a think, maybe pause the video, jot some notes, try and remember stuff before you move on. Okay, task 2. The electron structure. Can you draw the electron structure of the following elements? Helium, neon, and argon. This is a good recap over previous lessons. Little extension task. What could the electron configurations tell us about their properties? So pause the video before moving on. So you'll have to find the electron configurations, but essentially the outer shells are full, and therefore if it was helium it would just be 2, if it was neon it would be 2, 8, if it was argon it would be 2, 8, 8. Now, third task, noble gases. What can you say about the electron configurations of group 0? Well, they all have full outer shells. What does this mean in terms of their properties? Well, take a look at these 2 videos just here. The link will be in the descriptions below. And then can you explain why group 0 elements are unreactive? That is the main property that we are interested in with group 0. So watch those videos and then explain in your notes why group 0 elements are unreactive. So the videos told us a number of things in terms of properties. So we can see that helium, we've got an arrow pointing up here. Helium is less dense than air, so would rise up. And krypton just here is more dense than the air around it, so would sink down. And we saw that in one of the videos where the guy sat on the roof. Okay, the uses of noble gases, there's tons and tons and tons of uses of noble gases. There were some mentioned at the beginning of this lesson on the left-hand side, and there were plenty in those video links as well. But why? Here's an extension question. Why is helium less dense than air? Why is krypton more dense than air? Ooh, it's all about the numbers on the periodic table and the composition of air, and it is definitely worth looking up and trying to find out an answer for that one. So we've done group 0. Group 0 are unreactive. They're unreactive because they have a full outer shell. Now we move to the middle of the periodic table and the transition metals, and specifically what are their properties. So from left to right across the top, they form wonderful coloured compounds. We have some great different colours related to the transition metals. Their compounds, they're fantastic. They give rise to a lot of the colours in gemstones, for example. They are excellent catalysts. A catalyst is anything that speeds up the rate of a chemical reaction and doesn't get used up itself. So catalysts are really, really helpful in chemistry. They also have high melting points. Think about your copper, your nickel, those things that are used, those metals that are used to make coins. We need them to have really high melting points, otherwise they're going to be pointless as being used as money. There are some exceptions to that. One of them, for example, is mercury, Hg. They are malleable, just like other metals. They can be moulded into shapes. They're good conductors of heat and electricity. Just think about the fact you have got copper, that's a really good conductor of electricity, and then other metal contacts to help conductivity in electrical devices like gold, for example. They are also hard and strong. Think of your titanium hip replacement if you happen to have one of those or know someone that does. They are very, very, very strong metals, and also quite often some of the transition metals are fairly unreactive as well. Titanium, you want it to be unreactive, otherwise you're going to have all sorts of problems with that hip joint that's been placed inside your body. So another opportunity to go to your blank periodic table that's probably looking not so blank now. Highlight the elements in the transition metals in the centre and label it as well. You might already have some information in there about maybe iron, cobalt and nickel, so the magnetic elements. Maybe you've linked to a few of them in a few examples because you've got your metals and non-metals line fairly close to that as well. You should have labelled group numbers 3, 4, 5, 6, 7 and 0. You might have labelled your periods down the side as well. So there's all sorts of information that we've got around our periodic table now. Right, task number 4. Why is something used to make something? So we've got some examples here. We've got jewellery, we've got a bridge, we've got wires, we've got a hip joint. You can see an x-ray of a titanium hip joint. So 4 questions. Why is gold used to make jewellery? Why is iron used to make bridges? Why is copper used to make wires? Why is titanium used to make hip joints? Think of the reasons, pause the video and come up with your answers. Right, here's a slide that shows lots of information about some different metals. The gold for jewellery is up there. So gold is very malleable, it's expensive, it's very hard to find in its pure form. The fact that it's malleable helps us to shape it into intricate shapes in jewellery. Iron is actually quite brittle in its purest form and reacts with oxygen very easily to form rust, but it is, especially when you alloy it, it is very, very strong. So it could be used to make bridges, like in the previous slide. Nickel and zinc, they both have very high melting points. They're good conductors of heat. They weren't an example on the previous slide, but nickel was used to make coins. Zinc is good for galvanizing, so covering other metal surfaces to stop them from reacting. So galvanization can be used to cover steel, for example, to stop it from rusting. Copper, the use in wires, copper is a great conductor of heat and electricity, and it doesn't react with water, which is good, especially when quite a lot of pipes are made of copper. And it's quite small, but information on titanium just here. Titanium is a very light metal, very lightweight. It also has a layer of oxide on its surface, which stops water and air getting to the metal, making it resist corrosion, which is very important in the body. It's also very strong and it can withstand high temperatures. It is, however, pretty expensive because it has to be extracted from its ore with a large amount of energy, and it can be used for artificial hips, pipes in nuclear power stations, and aircrafts and racing bikes, because it's very, very strong but fairly lightweight. So there are your properties and therefore the reasons for using those metals for different reasons. Right. Here is an exam question. So these exam questions have come from Exam Pro, which is AQA's exam kind of software stuff that us teachers use. Pause the video and have a go at this. It's 10 marks, and so therefore give yourself about 10 minutes. Apologies if the font is very small, but yeah, pause and take a look and have a go. Okay, here's your answers, all 10 marks worth. Again, pause, have a look through and work out whether or not you've got things right or wrong, and give yourself a mark out of 10. And hopefully all these lessons that you've been watching have helped you to get a nice 10 out of 10 or there and thereabouts. And then here we go. We've reached the end of the topic. You should now have a completed set of notes on the periodic table around your periodic table. The whole point within this topic was just reducing all of the information down from the topic across a double page spread with your periodic table at the centre of it. So the challenge is now to commit that information to memory. Maybe you need to print out the blank periodic table again and see what you can add without checking your notes. So can you add all the information around the periodic table without having to go back and check and look? So yeah, try and commit all of that to memory. Maybe, like I said before, you want to add little flaps and things over the top of your notes to kind of hide your notes. Put your keywords and your definitions on flashcards, or create bullet point lists down the side, whatever it might be, whatever you find helpful. And hopefully this video and all the others from the topic have been helpful too.